Hi there. In this lesson, we're going to be looking at adding and subtracting rational expressions. And we're going to do this in two parts here. So this is the first part that we're going to look at. And once again, we're going to compare this to what we do when we're dealing with fractions with just plain old numbers. And so if I consider these first two examples, if I look at the first one, in order to add two fractions, what I need is common denominators. Okay, I can't add two fractions that have different denominators. So for this one, right now the 12 and the 36 are pretty similar in a way. I can turn a 12 into a 36 by multiplying by 3. And so what I do is I multiply this first fraction by 3 over 3. Remember, I'm always multiplying by a form of 1. And whatever I do to the denominator, I have to do to the numerator. And by multiplying by 1, remember, something times 1 is always itself. So what I'm doing when I multiply by a form of 1 is changing what the fraction looks like, but not really changing the value. So this gives me a 15 over 36. Now the denominators are the same, so now I add the numerators, the denominator stays the same. Okay, so I do the 15 plus 7, which gives me a 22, over the 36 plus 36, I just leave those the same. Remember, that's why we needed to get common denominators. The mistake that we make is we add those 36s together. Remember, if I have like 15 pieces out of 36 total, and I have 7 more pieces out of the 36 total, I have 22 pieces out of the 36 total. And this reduces to an 11 over 18. Okay? If I take a look at the next one, again, I want to get these common denominators. So I'm going to look at a 4 and a 3. The greatest or the least common multiple here is going to be a 12. So I have to multiply the first fraction by 3 over 3. I have to multiply the second fraction by 4 over 4. The first fraction, when I do that, that's going to give me a 9 over 12. The second fraction here, when I multiply this, that's going to give me a 4 over 12. Now I have common denominators. I subtract the numerators. 9 minus 4 is a 5. The denominators stay the same, so it becomes a 5/12. Okay, and that's it. So when we're dealing with fractions, we need to have common denominators for addition and subtraction. So when we apply this to rational expressions, we want to do the same thing. We want to find common denominators, which can be a little bit tricky here, but we want to find common denominators, the least common multiple. Then once we have common denominators, we're going to add or subtract the numerators, and we're going to leave those denominators the same. All right? And then the last thing we do is always look to see if we can reduce the fraction that we're left with. Okay? For example, if I look at something like this, these already have common denominators. They both have a 3y as the denominator, so I add the numerators. Denominator stays the same. When I add those numerators together, the 4 plus the 7 gives me an 11. Over, the denominator stays the same. It's the 3y. And that's it. This one can't be reduced, so I leave it the way it is. Here, once again, I already have common denominators. I add those numerators. That gives me a 4x. Denominator stays the same. That's an x minus 2. And the only way to reduce this would be to factor it and look for common factors. But none of this factors any further, so that one's done. If I look at the next one, now we're subtracting. And just be careful when you're doing your subtraction here. I want to do the 9x minus the 3x, which is a 6x. And then the negative 3 minus the 5 is a negative 8. And if you're having trouble following along with what I just did, the easiest thing to do is just to change this to adding the opposite. Okay? And now I can clearly see the 9x plus the negative 3x is a 6x. The negative 3 plus the negative 5 is a negative 8. The denominator stays the same, 10x minus 4. And now from here, it looks like I can factor a 2 out of that numerator, which would leave me with a 3x minus 4. I can factor a 2 out of the denominator, which leaves me with a 5x minus 2, which means I have a common factor of 2 that I can cancel out. So my reduced form now is the 3x minus 4 over the 5x minus 2. And that's it. If I look at the next one, again, I already have common denominators. I would change this to adding the opposite. And now I combine these like terms. That's going to give me a 3x and a plus 2 when I add these together. The denominator is going to stay exactly the way it is. That's the 3x squared minus x minus 2. But then from here, I might try to reduce this thing. And in order to do that, I need to see if this 3x squared, I'm going to take it off to the side, minus 2 is going to factor. So I build a bridge. That's a negative 6. Two numbers are a negative 3 and a positive 2. I split up in the middle term and do my factoring by grouping. That's going to be a 3x squared minus 3x plus 2x minus 2. I group the first two together, group the second two together, so I'm doing my factoring by grouping. Out of the first two, I can factor out a 3x, which leaves me with an x minus 1. Out of the second two, I can factor out a 2, which leaves me with an x minus 1. So now my two factors are the x minus 1 and the 3x plus 2. So now if I look back at my fraction over here, I've got a 3x plus 2 over this thing factored into a 3x plus 2 and an x minus 1, which means I can reduce this fraction. Let me get rid of this work so it's not in my way here in case I need a little bit more space. I can reduce this because the 3x plus 2's cancel out. Since I've reduced this using division, that means I'm left with a 1 in my numerator and just the x minus 1 in my denominator. Okay? So again, subtraction, change it to adding the opposite makes it pretty easy. I add or subtract the numerators, denominator stays the same, and then I reduce what's left over. Okay? If I look at something like this time I don't have common denominators. So just looking at these things, if here I have a 3 times a y and here I just have a y, in order to make these things the same, this guy needs a 3. In other words, I need to have all the same factors here. See, this has two factors, the 3 and the y. This only has one of those factors, so I need the other factor of 3 here. So I multiply that first fraction by 3 over 3. When I multiply this first fraction, again, this is just my distributive property. That's how I would multiply these two things. So it would be a 3x plus 6 over the 3y. Now I have common denominators. I add the numerators. That gives me a 7x plus 6. The denominator stays the same over the 3y. I look to see if I can factor this to reduce the fraction at all, but this one I can't. Okay? If I look at something like this guy, right now I can see that this has a couple different factors. This is like a 5 times x, and this is a 2 times x. And really it's just a matter of making sure everything's got the same factors. So over here, this one needs the 5. That's one of the factors it's missing. And it also needs another x. Okay, so I multiply by 5 over x and 5 over x. Over here, this fraction, it needs the 2. That's the factor that it's missing. It already has enough x's, so this one just needs a 2. Right? So I'm comparing the list of factors here. This one's got a 5 and 2 x's, so now this one needs 2 x's and the 5. This one is just missing the 2. All right? So I basically look at the list of factors and give each fraction what the other one has, so that they all have the same factors. And what happens here, the numerator for this one, that gives me a 6x. The denominator becomes a 10x squared. Over here, this numerator is going to be my distributive property. That's going to be a 5x squared minus 5x. The denominator is now a 10x squared when I multiply it. So when I multiply it out, because I have all the same factors, I get the same exact denominator. So now subtracting is the same as adding the opposite. So when I do that, I'm going to put this in descending order. That's a negative 5x squared. When I combine those like terms, that's a plus 11x all over the 10x squared. And now from here, it looks like in that numerator I can factor out an x. In the denominator, it looks like I've got a 10x squared, which means a 10x times x. So one of these x's cancels out. So now the reduced form of my fraction is the negative 5x plus 11 all over just a 10x. Okay? So I get common denominators. I add or subtract the numerators. Denominator stays the same. If I look at the next one, again, look at the factors, and this is already in factored form, which is important. Over here, this has a factor of 4 and an x minus 2. This one only has the 4, which means in order to get common denominators, all this denominator needs is the x minus 2. It needs the factors that the other one has. They already each have the 4. This second fraction just needs the x minus 2. Whatever I do to the denominator, I have to do to the numerator. I'm multiplying by a form of 1. So this first fraction is fine the way it is. This second fraction, I'm going to go ahead and multiply. This is once again my distributive property. That's going to be a 3x minus 6. Down here, I'm just going to leave this in factored form. And the reason I don't multiply out the denominator, I have to multiply out the numerator so I can combine like terms. But the denominator, I don't need to, so I don't bother. Okay? I'm going to change this subtraction to adding the opposite. And now I combine like terms. Looks like that's going to give me a 4x and a plus 11. The denominator, I just have the 4 and the x minus 2. And that numerator is not going to factor, which means there can't be any common factors that cancel out. So that's it. Okay? If I look at this, take a look at this next one. Let me erase this to give myself some space. But when I look at the factors, over here, this has a factor of x plus 1 and an x minus 3. This only has the x plus 1. The thing that is missing is the x minus 3. Okay, so I give this first fraction the factors that it's missing. It's missing the x minus 3. Whatever I do to the numerator, or denominator, I have to do to the numerator. Once again, I see my distributive property. That's going to be a 6x minus 18 over, once again, this denominator I'm going to leave in the factored form. I've got the x plus 1 and the x minus 3. This second fraction stays exactly the way it is. Now I have the same denominator in each. They all have the same stuff. So I add those numerators. That's going to be a 10x and a minus 15. The denominator, that's going to be an x plus 1 and an x minus 3. And then from here, I might try to simplify this thing through factoring. The numerator I can factor out in a 5. But really, it doesn't do me any good to do that because nothing cancels out. So I could have left my answer like this, or I would also accept this as an answer if you want it in factored form. Okay? If I look at something like this guy, again, we're comparing the factors here. This has a factor of x plus 4. This one has a factor of x minus 5. They don't have anything in common, but still they want what the other one has. In other words, right here, this x plus 4, in order to look closer to the other fraction, it needs that factor of x minus 5. And so now this first fraction now has an x minus 5 and an x plus 4. It's got these two factors. The only one that this second fraction is missing is the x plus 4. So I essentially just make a list of factors and say, okay, which factors does the first fraction need? Which factors does the second fraction need? So that they all have the same factors. And now we can see that they each have the x minus 5. They each have the x plus 4. Now we'll have common denominators. They'll have the same two factors in each. Okay. This first numerator, in order to multiply this, I'm going to have to use my distributive property. Remember, I distribute the x, and then I distribute the 5. Okay? So I'm using my distributive property here. That's going to give me an x squared minus x minus 5x plus 5. The denominator I'm not going to multiply out. I'm going to leave it in factored form. The only reason I multiply out the numerators is because I need to be able to do like terms, and I can't see my like terms unless I do my distributive property. So here I distribute, that's a 4x squared plus 16x. The denominator, once again, is exactly the same as the other denominator. I've got the same two factors. So now I can combine those numerators. I just start combining like terms. Here I have like terms, and that's also a like term with this 16 that I'm going to add. So I'm going to combine all these at once, and then also the x squared plus the 4x squared. That's going to give me a 5x squared. The negative x and the minus 5x is negative 6x, plus the 16x is a plus 10x. And then we also have this plus 5 that didn't have any like terms, but it still tags along for the ride. And then from here, this is an x minus 5 and an x plus 4. From here, I might try to factor this thing if I take that numerator off to the side. Just because we always want to check to see if I can reduce the fraction. I always want it in the simplest form. I can factor a 5 out here. That's an x squared plus 2x plus 1. And now from here, the x squared plus 2x plus 1, I can build a bridge. I can factor that into an x plus 1 and an x plus 1. So it looks like this is not going to reduce, so I can leave my answer this way. If you want to write it in factored form as the 5 and then the x plus 1 squared over the x minus 5, x plus 4, that is absolutely perfectly acceptable as well. Okay? So again, we need common denominators. To do that, we make sure each denominator has all the same stuff, and then we add or subtract the numerators. Denominator stays the same.